Hey guys, good morning. I'm going to walk you through how to complete 7.4 section, which is in your textbook, page 209, for the homework questions. So in this section, you'll be learning how to factor simple trinomials. Okay, so in terms of factoring simple trinomials, I will admit this is probably the trickiest section, or at least one of the trickiest sections in the course. However, I feel as if you know the skeleton format of it, everything should work out fine. Okay, so I'm going to go really slow. If you need to rewatch the video, remember you can always rewatch a video. It always makes sense doing something a second time, especially for absorbing the concept so that you understand. Okay, and of course, please ask me questions like you guys have been doing. If needed, we can also have one-on-one Microsoft Teams meeting where we get to communicate online, and I can put up a whiteboard and answer any of your questions in real time if needed. So let's take it to what you do know. All right, so something that you do know how to work through is how to expand, how to expand 7 plus 5, sorry, x plus 5, x plus 2. Okay, so like we were doing earlier, this was our first section, our 7th chapter in the textbook. We discuss how to expand, which is through the method of FOIL. Okay, so I'll do this one together with you. This is like saying, well, what is x times x? You know that's x squared. That's our first. This is our outer, x times 2, which is plus 2x. This is our inner. And then this is our last. All right. We collect our like terms, so you'll notice we have 2x plus 5x as like terms. So when we put them together, we should have x squared plus 7x plus 10. We ended up with a trinomial after we expanded and simplified what was given to us as first two binomials. Okay, so what we're actually going to do today is we're going to do the opposite. Okay, so we're going to learn how to get from here, and this is our start point, and we're going to transition into this. Right, so remember that idea of factoring just meaning unmultiplying. Okay, so when I do that action of unmultiplying, that's going to require something called factoring a simple trinomial. Okay, let's do another expand one just one more time just to ensure that we have that skill under our belts. So we should have x squared, I should have plus x, I should have plus 4x, that's my inner, and then my last plus positive 4. Okay, once again we collect our like terms. For our like term collections, remember 1x plus 4x is 5x, and then the plus 4 that's at the very end are constant. Okay, so once again we're going to learn how to go from our answer to our question. That's going to be our skill for today. Okay, now I'm going to take us back to this question here, which was beside our first question we completed, and our instructions are factor x squared plus 7x plus 10. So essentially I'm starting at my endpoint of the previous question. Okay, so I'm going to write x squared plus 7x plus 10. Okay, now what you'll notice is how we started was with two binomials. Okay, so let's just consider what's been a repeating pattern. Okay, I always have two binomials. If you'll notice, this position will always involve an x. Okay, now what comes after that part is not always consistent, because if you look at our first answer, we got x plus 5, x plus 2, and then our first answer, first question, then our second question was x plus 4, x plus 1. So obviously we're given different numbers. And when we've done this in 7.1, we've done it with different integers. Okay, so we've done them even with positives, we've done them with negatives. So there's different arrangements. Actually, I won't do that. For here, these are integers. Okay, now we might want to think of how they're related. Okay, so again, we had, as our answer, we had a plus 5 and a plus 2. And I know that I need to insert them in these blanks in green, but how are they related to plus 7x and plus 10? Okay, so let's give a second just to think about that. We have a plus 2, we have a plus 5, and they're somehow related to this trinomial, or at least the spaces in the middle term and the last term. Now you might notice 2 and 5, if we multiply them, 2 times 5, so if we do this, we do get 10, okay? And at the same time, if we add 2 plus 5, we also get 7. Okay, so these are just things that we're noticing right now. We can take that same notice here. Okay, so we look at our numbers, we got a plus 4, we got a plus 1. In our trinomial, we have a plus 4 at the end, and then plus 5x in the middle. Okay, so if we think about this, the numbers that we were given, plus 4 and plus 1, if I do the same thing, if I multiply those two numbers, I do get plus 4, which actually happens to be my constant at the very end. And if I add these numbers, I actually get my middle term, just without the x, just the middle term number. Okay, so there is a relationship between them. Now, today we're going to figure out what that relationship is. Okay, so in factoring, we need to find x squared plus bx plus c. Okay, so we're going to learn about how to factor simple trinomial factoring. Okay, and we're going to use this method. Okay, I call this method MAN as an acronym. Okay, so it's trying to figure out what multiplies, that's what the M's for, to C, and you got it, adds to B. Okay, N stands for what are those numbers. Okay, and those two numbers have to be very exclusive in terms of your integers and have to make sure it satisfies they multiply to the C term, they add to the B value, and then stating those numbers will always follow this skeleton. But what we got to figure out, oops, I want a different color. What we got to figure out is what goes in these blanks. And those are our numbers. Okay? So let's give it a shot. Let's try them out. Please use the multiplication table that I gave you. It is on Etsy. Or if you have your own in your agenda or one that you could pull up online, it does help with your starting process. Okay? So when you're working through factoring trinomials, always think about what numbers multiply and at the same time add to the number that you're trying to pursue. Okay, so let's start here. So in terms of MAN, I need to figure out what multiplies to plus 12 and adds to, let's just take the coefficient 7 and trying to figure out what those numbers are. Okay, So we can give it a try and just think about first what multiplies to 12. So take out your multiplication table. If you need to, pause the video, have it ready. Once you have your multiplication table, I want you to go through it and figure out what are numbers that multiply to 12. Okay, or if you know this, even better. We know 1 times 6 equals 12. I'm sorry. 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12. So there are 3 sets of factors, or 6 factors in total. Okay, so out of those 3 sets, which set, so that's set 1, that's set 2, that's set 3, which set also adds to 7? 3 plus 4. Okay, so this means your 2 special numbers are 3 and 4, because 3 times 4 equals 12. 3 plus 4 equals 7. They both work and they satisfy the conditions of what multiplies, adds to, given these numbers. Okay, so now we got to put it into the skeleton. Okay, so we start with x squared plus 7x plus 5 plus 12. We're going to put 2 binomial brackets. We always said they both start because it's simple with x. We're going to take these numbers and just insert. Okay? What do you think? Not bad? Let's try another one. Okay, let's try C. So for C, we have what multiplies to negative 4, what adds to positive 3, and we got to figure out what those numbers are. Okay, so when it's a negative in your product, which is what multiplies to, this can only happen in one scenario. You can only have a negative product if you multiply a negative times a positive. A negative times a positive will always equal a negative. So that means between your 2 pairs of numbers, or your pair of numbers, one of them has to be negative. Okay, so 4 is a simple one because there's only 2 options, right? 2 times 2 equals 4. 1 times 4 equals 4. Now I need a number that can eventually add to 3. So what I usually try and think about is which numbers have a difference of 3, because that's the opposite of addition. And then from there, thinking that when you add, because we're looking for a negative product, one of them needs to be negative, so that sum does become the addition, or plus 3, that I've been looking for. So for this, it would be 4 times negative 1. Because 4 times negative 1 equals negative 4, which is what I'm looking for. 4 added to negative 1 does give me a positive 3. Okay, so in terms of writing this out, we would have x squared plus 3x minus 4. Okay, we know each binomial will have an x at the beginning, and then we just fill this in. So we have a positive 4, negative 1. This is now completely factored. I'll just quickly do the ones on the side, B and D. I won't go into great lengths of explaining it, but eventually, if you have your times tables ready, it should be fairly straightforward. Okay, so this means that this would be x plus 4, x plus 2. Okay, multiplies to negative 18 and adds to negative 3. So this should be 9 and 2, no, 6 and 3, and then we'll take the negative 6. Okay, now I'm putting the negative 6 with that place, because if I add negative 6 plus 3, I get negative 3, which is what I wanted in the A part. play around with your calculator. It's always good to have your calculator handy for this lesson so that you can figure out what multiplies and adds to. Do a bunch of steps in terms of trying to pursue and see if it does multiply and add to this number. So take your calculator, try out your options just to ensure that you get the desired combo. There is not more than one answer. Okay, the only thing that you can rearrange is if you have this, you could write this as, well, this could be x plus 3, x minus 6. Its order does not matter for now. Okay, so its order does not matter. I just basically flip the pair. But again, if you were to FOIL that out, you would still come up with the same answer. Okay, last thing I'm going to talk to you about is how to figure out area. Okay, so area of a rectangle. These are very common questions that are asked. Okay, especially for like application type problems. And this will continue in grade 11, which is why I want to show it to you and go over it with you. Okay, so we're going to pursue the same thing. Our question reads, find an expression for the rectangle's area by factoring. So in terms of factoring, remember it's the last term, what multiplies to negative 28, and adds to our middle term, which is 3. So we got to think of numbers. What are two numbers that multiply to negative 28 and have a sum of 3? So in this case, 7 and 4 does work. Trying to figure out where to place that negative. Okay, so if I do negative 7 plus 4, that gives me a sum of negative 3, which is not what I want. But if I do 7 plus negative 4, I get positive 3, which is what I do want. Okay, so that means if I was to factor this, it would be area is equal to x plus 7 x minus 4. Okay, now this does represent to some degree area, and we know area of any rectangle is length times width. So we could interpret this as one of the lengths, or one of the sides represents length, one of the other sides represents width. Okay, so easily, like we did in 7.1, I know there was a tennis court question that represented this exact model. You can think of it like this. We just found the dimensions for the length and width by multiplying and adding. Okay, that's pretty much the essence of 7.4. There is an advanced version for example 3. Okay, I know given our quarantine season, what's more important is that you can do questions like 2 to 5. However, if you want to challenge yourself a bit, I'm going to go through example 3. Okay, if you want to just watch how I do it, no problem. But again, if you have the time and you want to give number 16 a shot, by all means. Okay, so factor the following. Hint, you'll need to find a common factor first and then the factor the trinomial second. So in terms of a GCF, so we did this earlier on in our common factoring section. Our GCF, we want to figure out, is there a GCF of these three terms? Okay, so we have 5x squared plus 35x plus 30. Now our smallest number is 5, and factors of 5 are 1 times 5. So that means the GCF can't be any greater than that, right? We can't say 6. Well, 6 doesn't go into 5 anyways. It goes into 30, but it doesn't go into 35. So in this case, our GCF does, in fact, just stay at 5. And it can't be 5x because our C value doesn't have an x. So it's just going to be plain 5. So I have 5, open bracket, x squared plus 7x plus 6. Now, with what I highlighted, something you might notice is in that trinomial, that might be something that you can in fact factor. Okay, so this goes back to this whole lesson on 7.4, right? Working through our MAN acronym. Keeping that GCF just at the very front, right? Once we pull that out, we are still able to factor. Okay, so it's what multiplies to our last value, which is 6, and adds to a sum of 7. So what are those two numbers? Multiples of 6, or factors of 6, or 1 times 6, and 3 times 2. I'm going to go with 1 times 6. because they give us a sum or addition of 7. Okay, bring down that GCF, and then we'll just continue our skeletons. Remember, two binomials, both have an x, and then we take these numbers that we came up with, so plus 1, plus 6. Okay. Okay, I'll leave off the video with that. If you want to try this one, go ahead, no problem. Hopefully you get the gist of it. I'd like you to complete page 309, numbers 2, 3, and 5. And if you can, try the advance. If it's all over your head, be patient with it, no problem. I know this is a little tricky, but just continue to practice. And yeah, we'll just end off from there. Okay, so please work through your questions that are highlighted just here. And if you have any